Number 27, we begin with an equilateral triangle that's inscribed in this circle. Its three vertices are on the circumference of that circle. So I've just drawn it out here. We know the perimeter is 852, and since it's an equilateral triangle and all the sides are congruent, then to find each of these sides, I can just divide 852 by 3 because they have to contribute equally to that perimeter. And so if I do 852 divided by 3, I get 284. So this is 284, 284, 284. The next key on this problem is where to draw the radius. If I draw the radius, say here or here, it doesn't help that much because of this little overhang. I'm not able to correlate this radius with any part of the triangle. I'm not able to use this radius to find any other part of this triangle when it's drawn like this or this. But if I draw the radii like this and like this, which each of these being w squared root of 3, w squared root of 3, this works out well because if I, for example, complete this and I draw another radius here, because there's 360 degrees going around the circle, each of these angles has got to be 120. So let me just simplify this, just delete those. This is 120. If I now go ahead and drop a perpendicular to create right triangles, each of these angles is going to be 60. Each of these is going to have to therefore be 30 because it's a 30, 60, 90. We know these two triangles are going to be congruent because they have this leg in common and they have the same hypotenuse. So that's hypotenuse leg, if you remember from geometry. Point is, these two triangles are congruent, which means these sides are congruent, which means they're each 142. And now we're in good shape because we can draw our 30, 60, 90. Let's just extract one of these triangles over here. We know if we call this 60, we call this 30, we call this 90. We know the hypotenuse is w squared root of 3, and the goal was to find w. We know the side across from the 60 here is 142. And so now we can find what we need to find because we know in our 30, 60, 90, the hypotenuse is 2x. The side across from the 30 is x. And the side across from the 60 is x radical 3. So let's use this to find what the sides of this triangle will be and therefore what w is. If 142 is equal to x radical 3, if I solve this for x by dividing both sides by radical 3, I get x is 142 over radical 3. And for now, I'll just leave the denominator like this. It's not rationalized, but it's fine. This is going to be 142 over radical 3. The side across from the right angle, the hypotenuse, will be 2 times this x. So if I pull this out here, 2 times 142 over radical 3 is going to equal my w squared root of 3. And now I have an equation I can use to find w. Let us clean this up a little bit. So this is going to be 284 over radical 3 is equal to w radical 3. And then what I'll do is I'll multiply both sides by radical 3. So I can get rid of the radical 3 here. And I get 284 is equal to w radical 3 times radical 3. Radical 3 times radical 3 is just 3. So I get 3w is equal to 284. And so w is equal to 284 over 3. That is a perfectly valid answer. If you put this into your calculator, you will get some decimal, 94.6 repeating. So another possible answer would be 94.66. So we just truncate. We write as many digits as we can and we truncate. Or you can do the same thing, but instead of truncating, we can round, right? Because there's a 6 here. So it'll round the next 6 up to a 7. So either of these, any of these three answers could work. 284 over 3, 94.66, 94.67. I'm partial to 284 divided by 3 because then I don't have to deal with the annoying decimals and the truncating or rounding and making sure I fill up the box as much as possible with digits. I think it's way better just to deal with fractions if you can. But either way, any of these are acceptable. We can also double check, just make sure that everything is consistent. Because this answer of w is equal to 284 over 3 is pretty messy. So let's actually go ahead. Let's see, is our triangle consistent with this value of 284 over 3 for w? So that means our hypotenuse would be 284 over 3 radical 3, because that was defined as w radical 3 here. We found that w is 284 over 3. The side across from the 30 is going to be half the hypotenuse. So if I take 284 over 3, square root of 3, and divide it by 2, I'll get 142 square root of 3 over 3. And then if I take this side right here, if this is x squared of 3. So it's got to be 142 radical 3 over 3 times radical 3. Or 142 radical 3 times radical 3 is 3. All that over 3. The 3's cancel, and we're left with where we started, essentially, which is that this side across from the 60 is 142, which is what we had in our original triangle. This right here, before we used 142 over radical 3 for that side, but notice if I go ahead and rationalize this, we get 142 times radical 3 over 3. So these are the same thing, right? 142 radical 3 over 3 and 142 divided by radical 3 are the same. They're just different forms. Long story short, this all checks out. So we are extra confident that our answer is right. And that again is 284 divided by 3. The last point I'll make about this problem is how to deal with a common point of confusion, which maybe you ran into trying to do this problem. When we looked at the hypotenuse, we saw that it was w radical 3. And that may throw us off given what the typical 30, 60, 90 triangle figure will look like, especially when you look in the reference area of the test, right? If we have a 30, 60, 90, we'll call this 60, we'll call this 30. In the reference area, they'll tell you the side across from the 30 is x, the side across from the 60 is x rat 3, and the side across from the 90 is 2x. And you may then look at this w radical 3 and be very confused because it's like, wait a minute, isn't that supposed to be 2 times x? Why does it have a radical 3 in it? Isn't this the side is supposed to be across from the 60 rather than the hypotenuse? And this is a very important subtle distinction. This diagram, which gives us these sides, tells us the ratios of the sides, right? This is a ratio of x to x rat 3 to 2x, or 1 to rat 3 to 2. These are these give us the components of the ratios of these sides of our 30, 60, 90. They do not tell us what the sides will look like in reality. So while the side across from the 60 we designate as x radical 3, it does not mean, as it was true here, that it's going to actually have a radical 3 in its side length. Same thing with the hypotenuse. Even though the hypotenuse is 2x, you can, as we saw here, have a square root of 3 as part of that hypotenuse. What matters is that they're in the right ratio. So as long as they're in the right ratio, they can look like whatever. They can have radicals or not, doesn't matter, as long as they fit this ratio. And again, when we pull out our sides that we had before, the side across from the 60 was 142. The x that we found was 142 over radical 3. We'll just use that form. And then the side across from the 90, the hypotenuse, was 284 divided by square root of 3 when we double that x. So notice, even though these look pretty weird, they are in the right ratio, right? If this is my x, 2 times that will be 284 radical 3, which totally matches what we would get. I know before we had 284 radical 3 divided by 3, but this is the same thing as 284 divided by radical 3. It's just the rationalized form. And then when you compare, say, this side to this side, if I go ahead and I multiply this x by radical 3, they cancel and we get 142. So even though we get kind of strange values here, right? You also can make this 142 times radical 3 over 3, and you can make this 284 radical 3 over 3. It's all the same. The point is they look weird, but they're in the correct ratios, and that's all that matters. So don't confuse what the actual side lengths are, like what they look like as numbers, don't confuse that with the ratios, which must be, if it's a 30, 60, 90 triangle, in this 1 to rat 3 to 2 ratio. That's the ratio, but how the actual values look and what they are may be quite different from what you would expect them to be, but they should still fit with that ratio.